This is section 8.2, multiplying, dividing, and simplifying radicals. We have 4 properties here. This one, thankfully, we don't need to worry about anymore because they finally made it so that I can avoid the questions and the homework that involve this. So just mark that part out. This first property is a special case of the second property. What this one says is if you are multiplying 2 square roots together, you can multiply what's underneath. So you can multiply their radicands and you keep the radical itself the same. Now remember that this is an understood 2 if it's not written. It's a square root. This is the more general case. And it says if you are multiplying 2 roots with the same index, so 2 square roots, which would be this case, 2 cube roots, 2 fourth roots, whatever, as long as their index is the same, you can do that as well. You can just take and multiply the radicands together. Property 3 is one we've already dealt with. If you're taking the square root of a fraction, you can take the square root of the top over the square root of the bottom. And this one goes general as well. As long as you have the same index, you can split up a fraction underneath a radical into, if this were a cube root, I'd have a cube root on the top and a cube root on the bottom. These also work in reverse. There will be times where we have something in this format and we'll want to go backwards. Okay? So our first few problems are just to simplify. And that means we want 1 radical. We don't want 2 or 3 or whatever unless we absolutely must. And we want it as simple as possible. There are rules that are sort of like the basic equivalent of reducing fractions. We have a standard way of writing our answers. Starting off here, the square root of 2 times the square root of 11. They're both square roots. And our first property says we can multiply underneath the radicals. And we get the square root of 22. Now, even after we learn more about simplifying radicals, the square root of 22 will not simplify any further. So that is our answer here. Your calculators can do some of this work. Okay? So if I have the square root of 2, make sure you get out from underneath that radical times the square root of 11. And hit enter, you do get the square root of 22. Okay, so let's try the square root of 5 times the square root of 6. They're both square roots, so I can multiply underneath, and I get the square root of 30. Now, generally speaking, I would need to see if the square root of 30 simplified any further. It does not. We have not gone that far yet. Okay. Now let's just simplify the square root of 24. It's only a single square root, so it looks pretty simple. But let me just show you what happens if you enter it in your calculator. And this works on the black calculator we have in the classrooms as well. 24. It gives us that. 2 on the outside, square root of 6. This is simplified form. I'm going to show you how we get there. These calculators will do small values for you. They cannot handle everything. And they only work for square roots. They don't work for cube roots or fourth roots or anything else. So we do still have to know how to do these by hand. Okay, so first of all, what's going on here? I can rewrite the square root of 24 as the square root of 4 times 6. Because 4 times 6 is 24. That's the same thing. Now, our first property said that if we had 2 things multiplied together and they were both square roots, we can multiply underneath. But this also works backwards. So if I have 2 things multiplied together, I can split it into 2 square roots. So this is the square root of 4 times the square root of 6. Well, we can do the square root of 4. That is 2. So I have 2 times the square root of 6. And just like where we don't write 2 times x, we write 2x, we write 2 square root of 6. That's an understood multiplication in the middle, which is exactly what we got right here. Okay, so that's what's happening. It's not the easiest way to get it done though, because, well, 24 is a fairly small number, but why didn't I break it up as 8 times 3 or 12 times 2? Why did I choose 4 times 6? Because I needed to find the largest perfect square number that went into it. And that can be very tricky when you're dealing with larger numbers. In the next video, we'll talk about other ways to get this done.